factoring quadratics, and we're going to focus on when a is a value other than 1. Remember, if it is a value of 1, we had a shortcut. We just needed two numbers that added to our b value. Oh, geez, hold on a second. There you go. Added to our b value, and they also multiplied to our c value. But when we have a value where a is a number other than 1, we have to use a bit of a different method. The method we're going to focus on is finding the factors of a and c, so the first and last term. So the factors of 6 are 1 and 6, and 2 and 3. And the factors of 4 are 1 and 4, 2 and 2. Now, what I want you guys to notice is this is a negative 4, right? And we know that two positive numbers can make a negative, so one of these values of these pairs of factors will have to be negative. But we're going to deal with that at the end. What I'm going to do is I'm going to set these up in columns. Okay? So these are the columns for the first terms in the brackets, and these are the columns for the second terms in the brackets. In other words, what I mean is when we go to put this into factored form, we're going to have two sets of brackets. Symbol would be f at x is equal to. And our first term in each bracket are going to come from one of these two columns, while the second terms in each bracket are going to come from one of these two columns. We just have to figure out what numbers. And in order to figure it out, we're going to multiply a set of columns by each other, and their product, or the answer, needs to add up to our middle term, which is positive 5. Okay? And you could say it's positive 5x, and you could add x's to each of these values if you like, if it makes it simpler for you, because they are technically factors. Okay? So, let's go trial and error. We'll start with the very first column. We have 1x times 1 and 6x times 4. That gives us 1 and 24. Any combination of that give us 5? No. Okay? But we still have to try going across also. 6 by 1 and 1 by 4, 6 and 4. Does that work? No. Okay? So we know the first columns together will not work. Let's try the second ones. 6 and 2 and 1 and 2. That gives us 2 and 12. Does that combination work? No. And is there any difference when I go diagonally across? No, because these terms are the same, we're going to have the same product. So what we discovered is the very first column won't work. Okay? So in other words, we should be using these two terms, but let's just make sure by checking. 2 by 1 and 3 by 4 gives us 12 and 2. Does that work? No. 3 by 1 and 2 by 4 gives us 3 and 8. Does that work? Yeah. Yes, there is a combination of 3 and 8 that will give us 5. So let's make sure. What value would have to be negative in this case in order for this to work? The 3. Okay, so I'm going to put some permanent lines in here. We said 2 by 4 and 3 by 1. So 3x times 1 is 3x. And we said we're going to make the 1 negative. So that will give us negative 3. 2x times 4 will give us 8x. And negative 3x plus positive 8x will give us positive 5x. And now, just to make sure that we did use this negative correctly, let's multiply these factors. What is negative 1 times positive 4? Negative 4, and that's exactly what this term is. So these are the correct numbers. So we know in the first number in each of the brackets, one of them will be 2x, and one of them will be 3x. Now this is the tricky part. Because we multiplied 2x by 4, the 2x and the 4 have to go in opposite brackets. So the positive 4 goes in the other bracket, opposite of the 2x. And because we multiplied 3x times negative 1, the 3x and the negative 1 will have to go into opposite brackets also. Okay? So if you want, I'm just going to write it all in black so it looks like a permanent answer here. F at x is equal to, and I'm not going to change anything from above except the color, 2x minus 1 multiplied by 3x plus 4. And that's the process to factoring when our value is something other, or a value is other than